legendary SR-71 Blackbird is making a comeback. The U.S. Air Force has just announced a modernized version of this iconic aircraft. This high-speed, high-altitude spy plane, once the fastest in the world, is set to soar through the skies again, equipped with advanced technology for the 21st century. This aircraft is ready to take on modern threats, laying waste to enemies with its lethal armaments and impenetrable armor. What are the features of this modernized airfighter? What are the other secret projects on which the United States is working? Join us as we explore the futuristic designs of the modernized SR-71 that the United States Air Force just announced. The world of aviation is familiar with the impressive features that Lockheed's SR-71 introduced to the world. This aviation wonder, which was a secret project developed by Lockheed Corporation in the 1960s, was a long-range, high-altitude spy aircraft that could fly at more than 3 times the speed of sound. Despite how renowned the Blackbird is, most people, when shown a picture of an A-12, would mistake it for an SR-71, if they recognized it at all. However, they are different aircraft with significant differences. Before we explore the features of what the modernized SR-71 is like, let's clear up this confusion. The A-12 was also a secret project that was developed at the end of the 1950s to replace the U-2, which had become vulnerable to Soviet missiles. Lockheed built 15 A-12s. Officially, the project was called Oxcart, but Lockheed unofficially named it Cygnus after the Swan constellation. The A-12 took its very first flight from Groom Lake, Nevada, on April 26, 1962, a top-secret location already used by the CIA to test the U-2. The A-12 was the fastest plane ever used in combat and was way ahead of its time. Of the 15 built, 9 remain, displayed in museums across the country. The SR-71, while impressive, didn't have the same allure as the A-12. It flew at similar speeds and heights, but had a 2-seat cockpit instead of the A-12's single seat. The Blackbird was publicly revealed in late 1964 and began flying in January 1966, while the A-12 had been flying in secret since 1962. However, the A-12 program ended in June 1968 because running both the A-12 and SR-71 programs was too expensive. Additionally, the Air Force wanted exclusive control over spy planes. Although the A-12 project ended, the planes were stored secretly, and the program remained classified until 1981. Comparing the two, the A-12 was slightly faster and could fly higher than the SR-71. The A-12 was also lighter but carried less fuel and had a smaller sensor payload, yet it only needed 1 pilot. Despite these differences, the A-12 and SR-71 were quite similar, hence the confusion. The A-12 is often considered cooler because it was faster, operated from the mysterious Groom Lake, was run by the CIA, remained a secret until 1981, and had an ingenious design. Only CIA pilots flew the A-12, and adding to its mystique, while Congress members occasionally got rides in the SR-71. The A-12's crash sites on public land are still hidden in secret. The A-12 could reach speeds of Mach 3.35, while the SR-71, although close, could reach Mach 3.2. Also, the A-12 could fly up to 95,000 feet, while the SR-71 could reach 85,000 feet. The Blackbird had a greater unrefueled range of 3,250 miles, compared to the A-12's 2,500 miles. Another thing that distinguished them was their weight. The A-12 was lighter, with an empty weight of 60,000 pounds compared to the SR-71's 67,000 pounds. The SR-71 could also carry a larger sensor payload, 3,500 pounds, compared to the A-12's 2,500 pounds. However, the A-12 would forever remain a legend in aviation history, combining speed, secrecy, and advanced technology. Moving on to the Blackbird and why it is considered special, it was first shown to the public in July 1964, and it started service with the U.S. Air Force in January 1966. The Air Force retired it in 1989 due to political reasons, but it was briefly brought back in the 1990s before being retired again in 1998. NASA then used it for research until 1999. It was equipped with the most advanced sensors, radar, and cameras for its spy missions. It flew very fast and very high, allowing it to avoid threats. If a missile was detected, it would simply speed up to escape. After its retirement, Rumors of a more modernized version of the SR-71 took the world by surprise, and the excitement doubled when it was declared real. The SR-72 is the Lockheed Martin project that's generating significant buzz in the aviation world. Often referred to as the son of Blackbird, it carries the legacy of the iconic SR-71 and aims to take things to the next level. Lockheed Martin, the world's largest defense contractor, sees the SR-72 as a versatile aircraft with an arsenal that includes guns, missiles, and even laser-directed energy weapons. It's designed for reconnaissance, surveillance, and intelligence gathering, and is equipped with state-of-the-art sensors and cameras capable of capturing images spanning nearly 100 miles. As other nations were developing anti-satellite weapons, area denial technologies, and fast intercepting jets, the U.S. recognized the urgent need for a new spy plane. This new aircraft had to be exceptionally fast, enabling it to enter protected airspace, conduct observations, capture images, and even potentially strike a target long before adversaries could detect or intercept it. These capabilities were beyond the reach of fifth-generation fighter jets or any known space programs. The SR-72 solves this problem since it has a projected top speed of Mach 6, which is more than 2 times the speed of the Blackbird. It can also reach this remarkable speed while flying at an altitude of 80,000 feet, equivalent to 3 times the height of Mount Everest. This implied that this aircraft could traverse the globe in just a single hour. The extraordinary velocity of the son of Blackbird is made possible by a combined-cycle turbofan scramjet engine, a technology in which Lockheed Martin has accumulated 3 decades of experience. This top-secret project has been in development since 2007. However, engineers at Lockheed Martin's Skunk Works had likely initiated research and development many years prior. Notably, NASA has invested $1 billion in developing the SR-72, potentially contributing groundbreaking technologies that could further elevate its capabilities. As a result of these advancements, the son of Blackbird is expected to come with a price tag of around $1 billion. Nevertheless, flying at such staggering speeds comes with an array of challenges. The aircraft must withstand the intense aerodynamic heating, which causes a significant increase in surface temperature. These temperatures are high enough to melt conventional aircraft materials. Consequently, the aircraft will need to be constructed from special alloys of metal and ceramic composites, similar to the materials used in space shuttles. What's truly remarkable is the application of 3D printing technology in constructing the aircraft. This advanced manufacturing technique allows for the creation of intricate components that were previously unattainable. For example, the cooling system will be 3D printed directly inside the engine. The application of 3D printing is set to revolutionize aerospace fabrication. While this might sound like science fiction, much of this research is grounded in the real-world experience of the Hypersonic Technology Vehicle 2, or HTV-2, developed in 2010 by the Defense Advanced Research Projects Agency, DARPA. The HTV-2 reached an astonishing speed of Mach 20 for 9 minutes, equivalent to approximately 13,000 miles per hour. However, the drone tragically lost control, and its autopilot initiated a self-destruct sequence, causing it to plunge into the Pacific Ocean. Nonetheless, DARPA believes that the knowledge gained from this project can be applied to the SR-72 program. As a testament to this, DARPA canceled a scheduled third test for a Mach 20 UAV. Looking to the future, this advanced version of the SR-72 may not solely serve intelligence gathering and reconnaissance purposes, but could potentially be equipped to deploy hypersonic missiles designed for precision strikes. The implications of this technology are nothing short of revolutionary, providing the United States with an unprecedented advantage in terms of reconnaissance and potential military capabilities. Hypersonic aircraft, when paired with hypersonic missiles, could potentially breach heavily defended airspace and target virtually any location across a continent in under an hour, as stated by Bradley L., Lockheed Martin's program manager. Speed represents the next frontier in aviation, vital for countering emerging threats over the coming decades. This technology, if realized, would indeed be a game-changer on the battlefield, much like the transformative role stealth technology plays today. However, as many researchers have noted, such advanced weaponry does not exist as of today. Creating hypersonic missiles and aircraft presents formidable challenges. Not only must engineers design rockets that can endure the immense heat and air friction experienced at hypersonic speeds, but they must also tackle the problem of maneuverability. How can a missile alter its course during flight when its turning radius might span hundreds of miles and consume copious amounts of fuel in the process? These hurdles are substantial and would necessitate groundbreaking technologies. Yet the SR-72 project offers more than just pure speed. It aims to address some of the weaknesses inherent to its predecessor, the SR-71 Blackbird. Thanks to contemporary technology, engineers can reevaluate the mission design of the Blackbird and rectify some of the flaws imposed by 1970s technology. These may include eliminating antiquated systems like the Space Shuttle-like countdown for launch, or the fact that the SR-71 had an extended turnaround time of over a week for a second flight. Moreover, the son of Blackbird has the versatility to be manned by pilots or operated remotely, making it incredibly agile and capable of withstanding greater acceleration and tighter turns with higher G-forces, eradicating some of the original aircraft's shortcomings. With this resolve to make the SR-72 the absolute best, for some people, there is no reason it's impossible for another supersonic like the Aurora to exist. Still, the US government has consistently maintained that the evidence supporting the existence of the Aurora is, at best, circumstantial and speculative. They offer little reason to contradict this official stance. Yet some remain unconvinced. Experts like Bill Sweetman, a writer and Black Projects Authority, believe that Aurora is more likely to be in active development than not. Recent technological advancements have made it possible for ambitions conceived a generation ago to be realized. Moreover, the mature state of hypersonic technology, as seen in the SR-72 program, indicates that it may have been used in other classified aircraft development projects. Intriguingly, a mysterious $9 billion budget black hole in 2006 has never been attributed to any existing Air Force program, including the B-2 bomber. The United States is not the only country investing into the building of really fast and advanced aircraft. Russia is also gearing up. This country, one of the few at the forefront of technological advancement, has also invested in the production of one of the fastest aircraft in the world. Implying Russia makes the highest speed performance aircraft may sound like a joke, especially with the release of this new supersonic aircraft. However, their effort needs to be recognized. The fastest Russian fighter jet is the Mikoyan MiG-31, a formidable supersonic interceptor designed for speed and precision. Known as the Foxhound in NATO documents, the MiG-31 is quite the speed demon. It boasts a top speed of 3,000 kilometers per hour, which translates to approximately 1,864 miles per hour. This amazing velocity allows the MiG-31 to fly past territory swiftly without being detected and intercept high-speed, high-altitude threats. The role of this fighter as a long-range interceptor is among what sets it apart. Its primary purpose is tracking, engaging, and neutralizing targets, especially enemy aircraft and missiles. With its top speed, it can rapidly close the distance between itself and incoming threats, making it a formidable defensive asset. MiG-31 is also equipped with powerful radar systems, which allow it to track multiple targets simultaneously and engage them effectively. Its ability to operate in the stratosphere is another distinctive trait, giving it an advantage in specific scenarios. As impressive as the MiG-31 speed is, it still can't stand the SR-71 or even the American YF-12. This YF-12, aside from the Blackbirds and the latest son of Blackbird, was an impressive creation by Lockheed. It was developed as an interceptor in the 1960s, designed to reach astounding velocities and intercept high-speed, high-altitude threats, particularly Soviet bombers. In terms of speed, the YF-12 broke the sound barrier with ease. It could reach speeds of up to Mach 3.35, which is roughly 2,275 miles per hour. To put that into perspective, it could cover about 1 mile per second. Such speeds allowed it to chase down and confront incoming threats with extraordinary efficiency. The YF-12's remarkable speed wasn't its only impressive feature. It was equipped with cutting-edge radar and fire control systems, making it a formidable opponent in the skies. In fact, it served as a testbed for technologies that found their way into other legendary aircraft like the SR-71 Blackbird. Nonetheless, the US is actively working on hypersonic aircraft, driven by the need to maintain its dominance in the face of formidable competition, particularly from China. Several U.S. programs, such as Project Mayhem from the Air Force Research Laboratory, aim to develop hypersonic aircraft. Project Mayhem focuses on creating a combined-cycle turbofan scramjet propulsion system that can propel larger payloads over longer distances than existing systems. In the early stages of flight, Mayhem employs these turbofan engines to propel the aircraft to speeds surpassing Mach 2. Once it hits this velocity, it switches to scramjet engines designed to operate at hypersonic speeds. Scramjets thrive on supersonic airflow, making them ideal for the aircraft's transition beyond Mach 5, potentially reaching speeds exceeding Mach 10. It also aims to land conventionally, bridging the gap between traditional aircraft and hypersonic vehicles. The challenges in hypersonic propulsion are substantial. Scramjets, designed for supersonic airflow, struggle with ignition at lower speeds, requiring assistance from other propulsion systems. Despite these obstacles, ongoing research and testing indicate promising advancements in the quest for practical scramjet engines. However, a slightly different approach comes from Dark Horse, a hypersonic, uncrewed, remotely piloted aircraft developed by the Atlanta-based aviation firm Hermes. Dark Horse employs a ramjet engine called Chimera with an $18 million combined cycle. Unlike scramjets, ramjets slow down supersonic air before igniting it, reducing engineering complexities and costs. However, this approach has some speed limitations, as it is expected to reach hypersonic speeds below Mach 6. To better understand the technical aspect of this endeavor, Hermes employs a turbine-based combined cycle engine, or TCC, which effectively merges the capabilities of a turbine engine with those of a ramjet. This hybrid engine can seamlessly transition between low-speed and high-speed operation, encompassing essential phases like takeoff, cruise, and landing. Hermes has selected the Pratt & Whitney F100 engine for the turbofan component of the Chimera engine. The Atlanta-based hypersonic firm recently made an exciting stride in aerospace technology by acquiring an F100-229 engine from Pratt & Whitney. This engine is renowned for its role in powering the USAF F-15 Eagles and F-16s. The F-100 engine will be the propulsive force behind Hermes' hypersonic Dark Horse aircraft, propelling it to incredible speeds of Mach 2.8 en route to a staggering Mach 5. This engine's transition from turbofan to ramjet power was successfully demonstrated in a wind tunnel in 2022, with plans to test it on the Dark Horse in 2025. This significant development was announced by Hermes earlier in June. According to the company's CEO, Ajay Piplika, the decision to upgrade to a more potent conventional power plant had been part of their strategic vision. This move aligns with Hermes' progression from their initial remotely piloted quarter-horse test aircraft to the more substantial and reusable hypersonic unmanned aerial system, or UAS, the Dark Horse. Looking further into the future, the company aspires to develop a 20-passenger hypersonic aircraft named Halcyon. To validate Chimera, the company is utilizing the Quarter Horse, a smaller testbed aircraft powered by the 5,000-pound thrust General Electric J85 engine in conjunction with a ramjet. This combination is designed to achieve speeds exceeding Mach 4. On the other hand, Dark Horse is poised to be a versatile aircraft with dual roles. It will function as both a payload-carrying hypersonic testbed and an operational unmanned aircraft catering to defense and intelligence clients. Dark Horse will be equipped with a scaled-up Chimera 2 propulsion system, featuring Pratt & Whitney's F100 engine, with an impressive thrust of 29,160 pounds alongside an in-house developed ramjet, complete with an inlet, pre-cooler, ram burner, and bypass system. This advanced setup will enable Dark Horse to achieve hypersonic cruise speeds. The United States is also working on another amazing project, a sixth-generation aircraft that would feature advanced technologies and take the aviation world to the next level. The Next Generation Air Dominance, also known as NGAD, is a project by the United States Air Force to develop a new kind of super-advanced aircrafts that will be even better than the formidable F-22 Raptor in terms of everything: speed, stealth, and even lethality. The project is aimed at redefining the future of air combat by enhancing air dominance capabilities in highly contested environments with improved lethality and survivability, departing from mere tweaks to existing technologies and instead reimagining the entirety of air combat's future, having originated from the goal of replacing the F-22 Raptor. This new fighter jet will have very advanced technology on board, including many different sensor systems, powerful electronic warfare capabilities, and a variety of weapons. It's supposed to use a new engine that can travel long distances efficiently and also move quickly when needed. The NGAD will also have strong computing and communication abilities to lead a group of unmanned systems and other air weapons effectively. It is important to note that this next-generation fighter is specifically designed for tough air battles in the Pacific and potential future conflicts with advanced countries like China. Thanks for watching. While you are still here, click on the link appearing on your screen to check out another of our videos. See you there.